This is Mr. Anderson for Kellogg Community College. We're going to be looking at intermediate algebra, Math 121, Chapter 4, Section 4, Inequalities with two variables. And this is just going to be some of the basics of graphing lines and shading them properly. A couple things that I want to do here is I want to create a little table for us here as kind of a guide. If we have less than, we're usually going to be shading below the line, and it's going to be a dotted line. Greater than will be shading above the line, and that also will be dotted. Less than or equal to is a solid line, and we will be shading, of course, below that line. And greater than or equal to is a solid line, and that will be shading above that line. We've always been, having like y equal to, which would be a solid line and there's no shading. So if we take a look at this, y is less than x, the y-intercept would be 0, because this is technically x plus 0, and the slope is 1 over 1. So I use this as a guide for our types of shading. Now notice that this is going to be a dotted line. And if I'm going less than x, then I have to shade underneath the line. So the shading will be underneath like so. Less than or equal to x, it's the same line except solid instead of shaded, or solid instead of dotted, and we're still shading below the line. Y is greater than x. Well, in this case, we're having a dotted line, just like we did in the first problem with less than x, and we're shading above because y is greater than that, because you think of our y as our vertical space, and here we have a solid line shaded above, where y is greater than or equal to x. Let's take a look at some of the different examples with some horizontal and vertical lines right here. Okay, here we have y is less than 2. Now, y equals 2 is a horizontal line, and a horizontal line is going to be dotted at that moment, and since y is less than 2, we're going to shade below here. And this is another dotted line here at y equals, sorry that my dots are not completely straight, but this is y greater than 2, so we're going to be shading above this. This is a vertical line. X is less than 2, so this is going to be a dotted line here. And this is going to be shaded in this direction because there's my x values that are less than 2. And here are my x values that are greater than 2, like so. All right, let's look at some slopes and y-intercepts and graphing those. Okay. Now, the first equation that we have is set up in slope-intercept form. So we are going to put our y-intercept at 3, and then our slope is 1 over 1, so we're going to go up 1 and over 1, up 1 and over 1 from each dot. This is a less than line, so it's going to be dotted, not solid. And since it's less than, we're going to shade below the line like this. Now this one right here, it probably would be good to use the intercept method. So to find my y-intercept, I plug 0 in for x, so there's my 4 for my y. And if I plug 0 in for my y, then I'm going to plug 4 in for my x here. See, if I do that to slow this down a little bit, how did I get that? I just said x plus 0 is equal to 4, and that's how I got the 4 for my x. And 0 plus y is equal to 4, and that's how I got my 4 from my y. Now, I'm going to graph this here. 0, 4 is 4 up. 4, 0 is 4 to the right here. This is a dotted line. And it's a dotted line, and we are going to go less than. And this is going to be true in all cases unless y is negative. Now, what might be good is to test maybe the origin. Testing the origin would be to plug 0 in for both of these. So 0 plus 0, is that less than 4? And it is, so we know we shade to the origin. Another way to have done this too is to take this and go y is less than negative x plus 4. That's moving the x to the other side. And there we would see that this would be starting at 4, moving down 1 over 1 like this, and this, and shading below. So many different ways to do this. Let's go to the next page. Got a couple ones where we have to do some single ones here. Alright, so in this case, the best way to do the problem is to, you could use the intercept method, but I think the slope intercept method is probably very valuable to us. So we're going to move that 3x to the other side, so we got 2y is greater than positive 3x plus 6, divide both sides by 2, y is greater than 3 halves x plus 3. So we start here at 3, and we're going to move up 3, 1, 2, 3, and over 2. Now, since we've gone off our graph right here, we can also go down 3, 1, 2, 3, and back 2 to get us that line that would be, accurate if we didn't want to extend that up there to the top there. Also, this is a dotted line, and it's greater than. Greater than works. All right. Now, we've got -4 and 2. Y is between -4 and 2. And remember, y equals numbers are going to be our horizontal lines. So when we have a y equals a number, this is going to be a horizontal line. So we're going to have a solid line at -4. So watch me try to make a solid line at -4. And a dotted line at 2. So we're going to have the shaded area between these two. This is kind of like saying we want y to be greater than or equal to -4 and, not or, but and y is less than 2. So this this kind of range right here is actually the range between these two numbers for all values of x. All right, going down to our final 4 problems. Let's do it 2 at a time here. This is where we have to compare the shadings of composite graphs on the same two-dimensional plane. So our first graph here has a y-intercept of 0, and it's going to start at 0, and the slope is going to be up 1 over 1. So up 1 over 1, up 1 over 1. It's a solid line because it's greater than or equal to. So I'm going to draw my line like this and just do some little up arrows there to show where the line would be shaded. Because I'm going to want to shade the lines where they actually meet. And you'll see that as I graph the next line, which has a y-intercept starting at 4. There's my y-intercept of 4, and this is going to go down 1 over 1. So there's my dot here, and there's my dot here. This is going to be another solid line. And that solid line is going to be shaded down like this. Now, the zone that's going to be inside the twin shades is going to be this section here. So it's going to be between the two lines. That's where the shading is going to be. Even though the blue line shaded up and the green line shaded down, this is the answer zone of the shades. If you put a dot in any of this Cheyenne zone here, that would satisfy both equations. Alright, let's look at the next one. Let me get back to my original colors here. Actually, let's change this a little bit. Okay, so this is x is less than 3. That's going to be a vertical line, so I'm going to put a vertical line, but it's going to be dotted. And it's going to be shaded less than. So I'm going to put my little arrows here to kind of show where I'm going to go. And then I'm going to take, let me change it to a different color. Let's go to, there we go. Start at, this is going to start at 2. Alright, so start at 2. And it's going to go down 3 over 1. So down 1, 2, 3 over 1. This is going to be a dotted line again. And this is greater than, so it's shading up. Shading up. Alright, and the area between both of these items, let me get this shaded in here, is going to be this yellow area between the two. Because the red line was less than, and the purplish line was greater than. Alright, 2 more to go. Alright, now this one. Let's check this out. I'm going to convert both of these to slope-intercept form. Let me get the color right here. Go back to blue. Alright, so that first equation, I'm going to turn that into y equals negative x, sorry, not equals, y is less than negative x plus 1. So it starts at 1. Excuse me. Y equals negative x plus 1. I'm going to move down 1 over 1 because my slope is negative 1 over 1. If you can tell, I'm doing this video as I have a small head cold. And this is going to be a less than equation, so we're going to shade down. Yeah. And here's the next one. We're going to then color this equation. We're going to transfer this. This is going to be negative y is less than negative x plus 2. I move the x to the other side by subtracting x. And then I have to get rid of this negative here. So this is y, which is greater than positive x minus 2. By dividing by negative 1, it changes everything to its opposite symbol, and the symbol flips. So I'm going to put my dot here at negative 2, go up 1 over 1 every single time. Another dotted line. And it's greater than, so it's going to be shading up. So you can see that the sector that it's going to create is going to be the spot between the part that's lower than the blue and higher than the light blue, which gives me this as my shaded zone. And the last one, not to be trifled with, this one can get a little bit tricky here, because what this is, it's giving you two zones. Whoa, sorry about that there. Let me clean that off here, and that will disappear this. All right. Whew. Okay, so first off, this will give us two zones, a zone between negative 2 and 2 on the y. So this is going to be a horizontal zone between 2 and negative 2. All right. And then we're going to get a vertical zone. Let me change colors here. We're going to change a vertical zone between 2 on the x and 4 on the y, or 4 on the x, I should say. All right, let me start that over here. All right, so my zone, and I'm going to color these in here. My zone in blue is going to be between these two lines, so between here and here. And my zone on the green is going to be between here and here. There we go. So if I'm between the blue lines and between the green lines, what's going to be my answer set? Well, my answer set is going to be this zone in this box right here. Actually, it's going to be in this area. So this is my answer, because the y values was between negative 2 and 2 horizontally. The x values was between 2 and 4 vertically. And so the combined area, shaded area between the blue, between the purple, is this black. All right, thanks for watching.